Hello, my name is Ethan Chitness, and this is Lab 2, the charge tapes revisited. So the purpose of this lab was to take the results from Lab 1, which we use a single point charge, and here's the experiment of doing that right here, and turn it into a line charge, or dividing the tape into segments, which are all calculated separately. The physics principles are the same as Lab 1. Newton's second law, that the equal and opposite reactions, which is going to be the force of gravity and the electric force later on. Coulomb's law, which is k cubed over r squared, or you multiply by another q to get electric force. And the gravitational force, which is F is equal to mg in this lab. And the results is that the Lab 1 had a 1.596 e negative 8 charge, and Lab 2 had a 2.4 e negative 8 charge. And those are different, and I'll explain why later on. And here's the Lab 1 results for comparison. The mass, length, width, separation are all the same in this lab. And the system and surroundings are also the same in this lab. This is the system surroundings right here. Yeah, they're all the same. And the calculations, so as I said earlier, Newton's second law. Well, first we have the force of gravity, which is the mass of the tape times gravitational acceleration, which is 2.548 e negative 3 newtons. And because equal and opposite reactions is the force of gravity is equal to electric force since the tape is motionless in the air. And then we can set that electric force is equal to k cubed over r squared, where r is the tape separation, to solve for the total charge of the tape. Here's the code behind that. So you have our constants here, tape mass, the charge from Lab 1, and then we have the tape length and the distance between the two tapes. All the same as Lab 1 right here. And then here is where the E field is defined and the line charge is defined right here in the code. This is what's actually going to make the stuff show up in the code and give all the definition to the line charge right here. And here is where we define the top tape and bottom tape line charge using this thing right here. And this n equals 50 right here, that's the amount of segments that was chosen for this lab. So it's going to end up dividing the E field into 50 different arrows, which you'll see in the code later on. Right here. So, and this is the nested for loop, which is going to go through and calculate the E field at all 50 divided points along here. On the red tape, the top tape, the blue tape is the surroundings, red tape's the system. And then you have a gravitational force, which is equal pretty much to the electric force here. And as you can see here, the force is nested through and calculated for each segment 1 through 50. So there's a couple of things that were assumed in this lab. That air resistance is negligible, which means we don't have to account for it in this. And we're just accounting for the electric force and the gravitational force. We assumed that each tape has the same charge. So they have equal charges here, which is also going to cause, it just makes them equal. And then we also said that the charge is uniformly distributed, which, as you can see here, it's a perfect distribution of the electric force, not like more on one side than the other. Which, in reality, error in stripping the electrons from the tape could have caused this not to be completely perfectly distributed, which is also a form of error, possibly. But the other two errors are the error in distance of measuring, which is difficult because human error measuring such a small distance with a ruler. And error in the environment. It was a pretty humid day, which could cause the charge to be messed up on the tape. So, comparing it to Lab 1, what if it was a point charge? The point charge of Lab 1 was 1.5963 e negative 8, and the line charge in Lab 2 is 2.4 e negative 8. And these are different because of the level of precision in calculation. This is just generalized as a point charge, but this is Lab 2, it's split up into 50 different segments, which cause for more precision and accuracy when calculating the actual electric force, because in reality it's not a point charge, it is an infinite distribution of these line charges. And because of that, the line charge in Lab 2 is a much more accurate representation of the actual tape's total charge. And that is all.